and welcome my viewers on my YouTube channel Mathematics with Usman. I am back today with my fourth video on the topic vectors, and today's tutorial is all about the use of position vectors. So let's dig deep into this topic straight away. Students, before starting the position vector, let us differentiate between the displacement vector and the position vector. Let us just consider the vector AB, which is moving 3 units in x direction and 2 units in the y direction. If I want to draw AB on this graph, the problem here is I don't know where this point A is and where the exact position of B is. Let us draw first the Cartesian plane. Vertical line represents the y-axis, horizontal line represents the x-axis. If I want to draw this AB, I can choose any position of my liking. Because the position of A is not specified, the position of B is not specified. Let's say the position of A, I choose this point as the starting point of this vector AB as A, and then its ending point will be 1, 2, 3 units in x direction, 1, 2 units in y direction. So AB vector will start from this position, end at this position, and its name is going to be AB. Students, see, I have the choice here. I can draw this AB anywhere in this Cartesian plane. If I draw it anywhere over here, again you can see it is moving 1, 2, 3 and 1, 2. 3 units in x direction, 2 units in y direction. So it is the same as the previous. If I draw it over here, A relative to B are again 3, 1, 2. 3 units in x direction, 2 units in y direction. So A and B can have any coordinates. I am not sure about their coordinates, but the position of B relative to A is always 3 in x direction and 2 in y direction. Okay students, now let's roll up our sleeves for the position vector. Consider any point P which is having an x coordinate equals to 3 and its y coordinate is equals to 2. Considering the location of points in a plane, it is very useful to refer their position relative to the fixed point O, that is called the origin, like this. If I refer this point P to the origin, I will get this vector OP. In the given figure, the displacement vector OP describes the position of P relative to the origin O, where OP is called the position vector of P relative to A. And if I want to write now the column vector for OP, then it is going to be 1, 2, 3 and 1, 2. 3 units in x direction and 2 units in the y direction. Students, we can consider any other points. Let's say it is Q having the x coordinate equals to 5 and its y coordinate is equals to -3. If I refer this point Q relative to the origin O, then I will get the position vector of this point Q, which is OQ, and whose column vector will be given as 5 units in x direction in positive sense, 1, 2, 3, 4 and 5, and 3 units in y direction but in the negative sense. If I want to find the resultant of these two vectors PQ, then this PQ is equals to OQ minus OP. Since it ends at OQ and it starts at OP, so end minus start is going to be the resultant vector PQ. If I subtract OP from OQ, the vector that I'm going to get is 2, -5 as indicated by this graph. 1, 2, 1, 2 units in x direction, 1, 2, 3, 4 and 5 units in the y direction but in the negative sense. Dear students, a significant consideration that we can make over here is just look the coordinates of the point P, 3 in x direction and 2 in y. Similarly, if you look at the position vector of P relative to O, which is OP, is also having the same coordinates as the point P, which is 3 units in x direction and 2 units in the y direction. If you consider the point Q, it is 5 and -3, And same goes for the position vector of the Q, which is OQ equals to the same as the coordinates of Q. However, students, the coordinates of AB, here the coordinates of A are different, B are different. Here the coordinates of A are different, B are different. So in the case of position vector, you are having the same coordinates of the vector as we are having the coordinates of the point. Now let's further explore the position vector with an example, and we will better understand its concept. So let us consider example number 1. Write down the position vector of A, whose coordinates are 2, 3, and the point B, whose coordinates are 4, 1, and express AB as a column vector. So first of all, let's draw first the Cartesian plane for this point A and B and plot them in it. So consider XY plane, vertical line, horizontal line, and this is the point O, which is the origin. Now see, where is the point A in the plane? It is 2 units in X direction and 3 units in Y direction. So this should be the position of A. If I need to find the position vector of A, what I have to do simply, I have to refer this point A to the origin. So this point OA. This vector OA is the position vector of A. Similarly, if you see the point B, it is 4 units in X direction and 1 unit in the Y direction. So it means that this will be the position of B. Now if I wish to draw the position vector of B, I will simply refer this point B to the origin O. So this is going to be the position vector of B, which is OB. The second part of the question says find the column vector for AB. So first draw what is AB. So B is starting from A, ending at B. And we can see clearly that this AB vector is 1, 2, 2 units in X direction and 1, 2, 2 units in Y direction, but in the negative sense. So the column vector for AB is going to be 2 units in X direction and minus 2 units in the Y direction. And this brings us to the end of today's tutorial. As always, thank you very much for watching. If you like my videos, please consider subscribing. See you in another tutorial. Till then, it's goodbye.